Welcome, builders, to the fifth installment in our series on programming fundamentals. Today we're going to talk about classes. So in the past we've talked about variables, data types, and functions. Well, a class rolls all of that together into one object. You can think of a class as encapsulating all the data into one object that can be manipulated and moved around the application. For instance, let's talk about student records. In the past, we had separate variables for like first name, last name, GPA, address, things like that. However, if we want to have that information to be passed throughout our application into different functions or different segments of logic, it gets tedious if we have all these variables, especially if we're dealing with multiple records. So instead, we can have what's called a class, where we have a set of variables or properties as they're known in classes. And then within that class, you can also have functions or what's known as methods within that class. So let's hop over the board and we're going to take a look. Okay, so here we are on the board and we're talking about student records. So let's create our variables that we would need. So we've got first name, last name, maybe a student ID, and GPA. So obviously a student record is going to have more information than that, but this will be enough to illustrate what we're doing. So if I needed to pass this student record into different functions throughout my application, you could see I would have to pass 4 separate variables. So all of my functions would need to have 4 input parameters for first name, last name, student ID, and GPA. And then if I were to add more variables for each student, that's more and more functions that I have to go modify to take in those additional parameters. So where classes come in is it wraps all of this and encapsulates it into one object. So let's illustrate what a class might be. So let's say I have a class and we're going to call it class student. Now these properties can be a part of this class. So classes encapsulate functionality. They encapsulate data through properties and then functionality through their methods. So like I said, now we have a student record that we can pass into our functions. So I've rearranged things a little bit so that we can see we have our student class that houses first name, last name, student ID, and GPA. But now, the other thing we can do with classes is house functions. So functions in a class are known as methods. One thing it might be nice to have the student class do is calculate the GPA. So let's have a method inside of our student class, and this is we're going to use the circular square here to illustrate a method. And this method might be calculate GPA. Okay? So now all of this is housed in one object that we can work with and we can manipulate through our application. And to do that, our code would look something like this. Var student equals new student. Okay? So our variable name is student and it is of type student. And then we would have like student dot first name equals Chris. Student dot last name equals Bryant. Student dot dot student ID is 1, 2, 3, 1, 2, 3, 4, 5, and student. Now, for GPA, we might want this to be a read-only property where you can't actually set the GPA, but rather it's something that needs to be calculated. So instead of setting student.gpa equals, we would have student.calculate GPA. And then let's say this method actually looks at their grades and then calculates what that GPA is, okay? So that's the overall concept of a class. It encapsulates data and functionality through properties and methods. So we're gonna hop over to Visual Studio and take a look at a real example. But first, I want you to hop over to github.com/buildsharper and clone the Course 105 repo on your local. That'll have the code examples that we're gonna look at. And if you're not familiar with Git, again, you can go back to Course 0. We do a quick overview of how to pull down a project with Git, or we have a course completely dedicated to Git, so you'll know the real ins and outs of it. So take a look at that and then come back. Okay, so here we are in Visual Studio. We have the Course 105 solution open, and we've got app 0, we're looking at program.cs. So at the top here, you can see we have two using statements. We haven't seen these before in our examples, but this is essentially a way to pull in other portions of our code. So after the using, these are known as namespaces where that code resides. So for this example, we needed buildsharper.course105.app0 and app0.models, which we'll take a look at here in a minute. So before we dig into the code, let's run it first and see what it does. Then we can take a closer look into how it works. So let's run it. Okay, so we can see all about fruit. The yellow banana weighs 118 grams, the blue blueberry weighs 2 grams, the green kiwi weighs 69 grams, and so on. So basically we're listing out fruit along with their color, their name, and how much they weigh. So let's hop back into the code and see how things are structured. Okay, so we've got a variable here, var fruits equals a new list of type fruit. Well, fruit isn't a data type that we've looked at before. It's a custom data type or a class. So let's go into our models folder and we can see we have fruit.cs. So let's take a look. We have a public class fruit. The public part we don't really have to worry about yet, but essentially that means it's accessible anywhere throughout our application. So this class fruit has 3 properties. We can see it's got a name of type string, a color of type color, which we'll take a look at that here in a second, and then it's got a weight, grams, that's an integer. So, and then we have a method, print, which will print the color, name, weighs, weight, grams. Okay, so we're encapsulating 3 pieces of data, name, color, and their weight, and then we're adding functionality by allowing this fruit to print, which will print out the type of fruit it is. With each of these examples, like I said, I like to introduce you to things you haven't seen yet so that we can cover it in another course, but at least you've seen it. And an example of that is going to be this color here. This is an enum. It's a data type where you can define what values go in it. So for example, a color, we can say the valid values for a color are blue, red, green, yellow, and orange. And these enums come in handy when we know what the valid values are for something. For instance, enums can be used for a status. So if we wanted to say if something is newly created or pending or in process or complete or failed, something like that, a status where it's a hard status where we can say the state of something. We might want to use enums for that. And then we can have logic based on that enum to say, okay, if something's in a pending status, do this. Or if it's a completed status, do this. So just so you guys have seen that, I wanted to do a quick tangent on enums. Let's go back into fruit. So we said a fruit has a name, a color, and a weight. And it can print itself where it'll do a console.writeLine with the color, name, and weight. So let's go back into Program CS. Now we can see we're loading up our fruits. So fruits.add, and then inside of this add, I'm instantiating a new fruit. So the first fruit is a banana. Its color is yellow, and the weight is 118 grams. Then we do the same for blueberry, kiwi, orange, and strawberry. Then all we're doing is a for each loop. So for each var fruit in fruits, which is our list that we created up here. So this fruits list that we just added our data to, we created instances of our fruit class with each one. And then we're just doing a fruit.print, right? So if I look at the implementation on this print, it's going to take me back to our method where we do our console.writeLine. Then we define the values of these properties when we instantiated each fruit, right? So that's pretty much it. Then we do a writeLine and a press any key to continue. So this is a pretty simple example, but it illustrates the use of classes to house data and then also provide functionality for those classes so that it's encapsulated. We don't have logic all throughout our code. It's all housed in this one fruit.cs file. So then if I needed to go change what happened whenever a print function, for example, is used, I can go change this in one place. So like we said with the student example, if we're going to calculate the student GPA, well, I don't want to have to calculate that in multiple places in my application. Remember, the DRY principle, don't repeat yourself. So if it's in one place in your class definition, it's easy to maintain. So while we're in Visual Studio, I want to take a look at our second application. We're going to go into App 1, and let's set this as our start project and run it. Welcome to Robo Rumble. Today's matchup is Optimus Prime versus the Terminator. Press A for Optimus Prime to attack, and press L for the Terminator to attack, and then press X to exit. So this is cool. So let's press A. Optimus Prime attacks the Terminator for 1 damage. Let's press L. Terminator attacks Optimus Prime for 18 damage. Well, this is cool. I can go back and forth. Okay, it was blocked. Terminator hits Optimus Prime for 30 damage. 18 damage. It was blocked. Cool, I can go back and forth. And then Optimus Prime has been defeated. The Terminator wins. Thanks for playing. Well, that was cool. So let's go take a look at the code and see how this works. So we're in our program CS. We can see this first line, we've got our using statement where we are pulling in Build Sharper Course 105 app1.models. So that namespace we are pulling into this CS file so that we can access the code in that other portion of our application. Okay, now welcome to Robo Rumble, and we're going to instantiate 2 robots. The first one is Optimus Prime, and I can see the second one is the Terminator. Then there's these 2 other properties that are being created, this 30 and 50. So let's take a look at what these might be. So if I do a comma here, it'll tell me one by one. So the first property that we send in is the name. The next is the max damage, and then the last one is the armor level. So if I were to go into our models, look at Robot CS. Okay, so we've got our public class robot. It's got a name, max damage, armor level. I have a Boolean, is alive, and then I have some private properties for current hit points, max hit points, and then this random. So first off, let's do a quick overview of public and private. Public means it's accessible from outside of this class or outside of this object. So the name, max damage, and armor level I can access those from outside this class. These private properties, current hit points, max hit points, and the random variable, those are private, so only this robot class can access those from within that scope. If I'm outside, I can do the public. If I'm inside, I can do the private. Okay? And then since these are properties, we have a get and a set. The get method defines what happens when I want to access this property. If I want to pull name, that's a get. If I want to define the name, that's a set. If I want to put a value in that name. And I can see this is a private set, which means only the robot can set the name. I can't, outside of this, say, for example, if I did robot1.name equals Fred. This won't compile because it's a private set, meaning only the robot class itself can set this value. Okay? So let's go back to our robot CS. So that's the private set. So how do you set that value if it's private? Well, we do that with what's called a constructor. A constructor defines how a class is instantiated. So a class is like a template. It defines, here are the properties that this class has, and here are the methods that it can run. But when you want an instance of that class, you use a constructor. So we can see we have this public robot. This is within our robot class, and then it takes in 3 properties: a name, a max damage, and an armor level. Now, here is where we can set those properties. I'm saying the name with the capitalized name, this property, is equal to the name that was passed in, and max damage and armor level as well, right? Because over in Program CS is where we're calling that constructor. We're saying, create an instance of this class with these properties. Optimus Prime, he's going to have the max damage of 50 and the armor level of 30. Okay? Now, then we're running a method. In this case, it's a private method. So meaning that only the robot can call it. And this is a reset where it sets the current hit points back to the max hit points. For example, if they start with 100 hit points, let's say they've gotten hit and they're down to like 2 hit points. If I did a reset, I would reset back to 100. And then also I set is alive back to true. So let's say they got down to 0 hit points and I set is alive to false. This reset would restore their hit points and then set that flag is alive back to true. Okay? But like I said, this is private. So if I'm back here in Program CS, if I tried to do robot1.reset, this won't compile. I don't have access to this method because it's not public. It's just private, meaning only the robot object can call it. Okay? So let's go back and look at robot CS here. Now, I do have a public method, take damage, and it passes in another instance of a robot. So we can see this take damage is going to take in a different robot object. Okay? So let's go back to Program CS. Let's keep going. So we define our robots. We have Optimus Prime and the Terminator, each with their own damage and armor. Now we're going to just have a little display for today's matchup and instruct the user on how they can attack for each robot, right? Pressing A will have robot 1 attack, and then L will have robot 2 attack. Okay? So we have our done variable to false, and then the exclamation point before done is a not. So not done is true. So while this is true, while it's not done, we're going to continue to execute this block of code. So I capture the input, I do a read key. Before we were doing a read line, which allowed us to type in and then press enter. In this case, as soon as they press the key, I want to capture that input and then run some logic on it. So once they hit a key, I do a console.cursorLeft equals 0, which just sets it back. As soon as for instance, if I type A, it's going to type A into the console and you'll be able to see it. But in this case, I wanted to hide it so that, let's run the application real quick. So you can see if I hit A, it says Optimus Prime attacks the Terminator and misses. But if I didn't do that cursor.left, you would see the letter A and then this message. So essentially cursor left equals 0 is just taking that cursor and moving it back to the 0 position, which is the beginning of the line. Okay? So that's all that's doing. Now we're doing a switch on the input key, whatever they typed. So I've got 3 cases. If they hit A, I do a robot 2 take damage from robot 1. And then if it's L, robot 1 is going to take damage from robot 2. So you can see, now that we have classes, we have the concept of objects that we can work with. These are now encapsulated so that they're easier to work with. Instead of having a bunch of variables, imagine if we needed to store like the robot name, their damage, their armor level. If we had all of these as separate variables, we would quickly end up having spaghetti code with variables all over the place. And it'd be a lot of code to maintain, and it just leads to more and more bugs down the road. So with classes, things are much more organized and easier to work with. You can see here, our code is pretty minimal because we've been able to house things and organize it using classes. And then finally, if they hit X, we set done to true, which will break us out of this while loop. Okay? Now, let's take a look at the take damage method. So I'm going to go to the implementation on this, and I can see the first thing I do is a check to see if they're not, if not is alive. So if they're not alive, then I do a write line of saying the enemy, which is the robot that got passed in. So you can think of the current instance of the robot is this that we're looking at. And then enemy is what was passed in. So say I'm robot 1 and robot 2 was passed into this method. So it would say robot 2 attacks, but robot 1 is dead. And then we return. Because we don't need to take damage, they're already dead. So this return breaks us out of this method. Okay? So if they aren't dead, we're going to continue our code. So we're going to calculate damage points. Damage points is equal to random.next from 0 to the enemy max damage. Well, this is a random number generator. What this does, it's going to return an integer between the range that we give it. And we're saying the range is from 0 to whatever the enemy's max damage is, which, as we could see when we instantiated our robots at the top of Program CS, I said Optimus Prime's max damage is 50 and the Terminator's is 70. Okay? So we're going to get a random damage amount between 0 and max damage. So we've got our max damage and we're checking if it's less than or equal to 0. It shouldn't be less than 0 because we're saying we want a random number between 0 and max damage. But in programming, we safeguard things. So just in case, for whatever reason, if it goes below 0, we can check against that as well. So if our damage points are less than 0, we say that they missed. So enemy attacks name, which is this robot, and misses. And we return because there's no need to continue with applying any damage because they missed, right? So now that we've made it this far, I have a new variable, damage, which is their damage points that we calculated up here, and I subtract the armor level. So they are kind of absorbing that damage that comes in. So let's say the damage points equals 50. Well, if my armor level is 30, that the resulting damage is then 20. Okay? So now, if the damage is greater than 0, I deduct that damage from the current hit points. So current hit points minus equals damage, which basically means current hit points is equal to current hit points minus damage. Or let's say you start with 100. Now it's equal to 100 minus 20. So then the new value of current hit points would be 80. Okay? And then we do a right line to illustrate the attack. So the enemy name attacks this robot's name for X amount of damage. Now this is if the damage is greater than 0. But since we calculated damage as the damage points minus the armor level, it's possible that's a negative value, which would mean they didn't damage them. So we would fall into this case in that instance. So enemy name attacks name, and it's blocked because their armor level was high enough to absorb that damage. Okay? And finally, if the current hit points are less than or equal to 0, again, we're safeguarding this in case it falls into the negative. Then we're going to print this name, this robot name has been defeated, and then we set is alive to false. So that is the robot class and its functionality. So that's the take damage. So for instance, we said if we hit A, then that means robot 1 is attacking. So robot 2 is going to take damage from robot 1. And then the inverse happens with L. Okay, now below our switch, and we apply the damage here, what happens below our switch? If not, robot 1 is alive. So if robot 1 is dead, then I'm going to write robot 2 wins. And we're setting our done variable to true, so we break out of that while loop. And the else if robot 2 is no longer alive, then we write robot 1 wins. Okay? Then we break out of our while loop and say thanks for playing. So that's it. This was a fun little application I put together to illustrate classes and the ability to house properties and data, but then also have functions or methods within those classes. So we have the concept of a robot with a name, damage, and armor, and then they can take damage from other robots. So we could see we could actually pass a robot object into another robot object and then work with that data. So again, we're encapsulating all of this functionality so that these objects are much easier to work with than separate variables. So that's a quick overview of functions. Essentially, they're a template for an object. They define a set of properties or variables within that class, and it also has functions or methods that can be executed on that class. So it encapsulates data and makes things easier to work with and maintain. As we said with the robot example, if we wanted to have separate variables for all of these things, for the robot name, their damage, their armor level, we can do that, but it gets to be a maintenance nightmare if it's all in line in one application. We have a separate source file for the robot object or class, and then we have our main application, which can then just work with those objects. It becomes much easier as our application gets bigger. We can use classes to organize our code and make things maintainable. So it's time for everybody's favorite segment, homework. So as always, the first part of the homework is to pull down the repo. So go to github.com/buildsharper, pull down course 105, clone it on your local, and run these examples that we went through today. And the second part of your homework is to create a new application. make a console application, and this is going to be the student example that we went through on the board earlier. So come up with a new class for a student, have a set of properties such as their name, student ID, and GPA. Make that a private GPA so you can't set that property. Instead, it's going to have a method, calculate GPA, where you can then run whatever routine you want to do to calculate the GPA. You can have a set of records that you want to add up and come up with an average, or you can just set the value. It's more about understanding classes with properties and methods. So the details of the calculate GPA aren't really that important. Once you have your student class, create some records, create some students, and display them on the screen. And then finally, get that checked into a Git repo on GitHub. Check it in, get it pushed up, and then share it with us on Twitter. You can tag us at BuildSharper. We'll be sure to give you props and a retweet. Or if you're struggling, you can reach out to us on Twitter as well, and we'll help you out. So that's all for now. See you next time.